Hello and welcome back. Let's have a look at this question. Consider the graphs of y equals x to the power of a half and y equals x to the power of a third for x is greater than 0. So I've just included those two graphs here, x to the power of a half in green and x to the power of a third in blue. 4a states or asks us to find the values of x for which x to the power of a half is less than x to the power of a third. So I think if you just have a look, you can see it should be between 0 and 1. Well, let's see if that holds. Don't forget, we've got this extra condition that x is greater than 0. Now, just this section over here, let's look at this. Let's use some algebraic manipulation to work it out. So if I put everything to the power of 6, let's see what happens. I will get x cubed is less than x squared. What? Does that make sense? Well, we're not done yet, don't worry. So let's just keep manipulating this. Let's make it x cubed is, minus x squared is less than 0. Okay, so far so good. Let's see if we can do a bit more over here. We can factorize. Let's take out the x squared and then we'll be left with x minus 1 is less than 0. So we can apply our null factor law or null factor theorem in this case. That just states that one of the factors must be 0 for this inequality to be true. So x squared is less than 0 and or I should state, x minus 1 is less than 0. So let's rearrange this. We could square root both sides. The square root of 0 is still 0. X is less than 0. And over here we've got x is less than 1. Now we've got a big problem with this statement over here because our original statement that the question gave us that x, or we're only looking at x greater than 0. So this thing down here, we do not care about. It is a useless answer. We've got a very nice answer here. X is less than 1. Now, if we combine that with our original statement that x is greater than 1, that would mean that we could combine them together and say that 0 is less than x is less than 1. So it just means between 0 and 1, x to the power of half is less than x to the third. And we can see visually, yeah, that's true. From 0 to 1, the green value is less than the blue value. Nice. Alrighty, let's look at question B now. Find the values of x for which the gradient of y equals x to the half is greater than the gradient of y equals x to the third. So we want the gradient of x to the half is greater than the gradient of x to the third. That's a perfect 3. Excellent. Okay, so gradients, what does that mean for us in this topic that we're doing? This just means the derivative of x to the half. So let's work out what the derivative of each of these terms is. So for this one, dy dx will just equal 1 over 2 x to the power of negative a half. We're just taking 1 off the power, and we've brought that power to the front. So 1 half x, the power was a half, minus 1, you get negative a half. Over here, dy dx, that's going to be 1/3 x to the power of negative 2/3. Okay, well, let's see what we can do with this. So we could state that 1 on 2x to the power of a half. I'm just changing the negative powers to positive by putting them on the other side of the fraction. and is greater than 1 over 3 x to the power of 2 thirds. Okay, let's work on this. Let's start by getting the x's out from the bottom. So we'll multiply both sides by x to the power of a half. We'll get 1 over 2 is greater than x to the power of a half over 3 x to the power of 2 thirds. I don't like that x to the power of 2 thirds on the bottom there of that fraction. Let's multiply both sides by x to the power of 2 thirds. And then we get this. Okay, not bad, not bad. Let's keep going. Let's see what we can do here. Let's use our trick we did before. Before we were working with fractions, we didn't like them. Whole numbers were just a bit easier to work with. So let's do the same thing here. If we do the power of 6 to both sides, that will eliminate the fractions from both sides of the inequality. So we'll just continue that here. We'll get x to the power of 4 over 2 to the power of 6 is greater than x to the power of 3 over 3 to the power of 6. Okay, this isn't too bad at all. Let's get all the x's on one side now. So we could have x to the power of 4 over 2 to the power of 6, x to the power of 3 is greater than 1 over 3 to the power of 6. These x's, these can cancel out. So x cubed, that's gone. And we take 3 off there and we're left with just a 1. Fantastic. Now, of course, we've got to be careful when we're dividing by x. X could be 0, but if you remember, our basic information says that x must be greater than 0. So this step here, that's a-okay, no dramas there. You're not dividing by 0. So we've got x over 2 to the power of 6 is greater than 1 over 3 to the power of 6. Let's get the x on its own. X is greater than 2 to the power of 6 over 3 to the power of 6. So find the values of x for which the gradient, so this statement, so for this statement, what does x have to be? And we've got that here. So we haven't changed the statement. This statement led us to this. So for this to be true, the statement that the gradient that x to the power of a half is greater than the gradient of x to the power of a third is that x is greater than 2 to the power of 6 over 3 to the power of 6. You can work that out on the calculator if you'd like. It's not a big deal. But that's all we've got time for today. Thanks for joining me, and I will see you next time.